Hey everybody, happy Tuesday. Um, 1 week from today and it's our last day of school in 2020. That's got to be something. That's not bad, right? So that's exciting. Yesterday we talked about the absolute value function. And today we're going to talk about what the absolute value function kind of is. All right, we're going to talk about a piecewise function. And a piecewise function, piecewise. I before E except after C. Piece. Yeah, that's right. A piecewise function is basically what an absolute value function is. It is saying we have one equation over one interval, and then we start another equation from a different interval. So if you think about the parent function that we talked about yesterday, it looked like a V. We had something like this. We talked about how it had a line of symmetry, right? And it looks something like this. Excellent. Oh boy, that's a really bad drawn line. Okay, we'll forget that first one even now. So, really, where are we getting this from when we do the absolute value of x? Well, really what's going to happen here is we have two lines. We have this line, right, that is increasing at a constant rate of change. And that would just be the line y equals x. But then we also have this line. And this line is actually y equals negative x, right? Because when x is negative, all of these turn out to be positive. Well, in our normal line, like y equals x, these would continue to be negative numbers, wouldn't they? But the absolute value is going to make those positive. And over here, when we plug in a positive x on this side into this one, the absolute value is going to flip those and make them positive as well. Because obviously if you plugged in like positive 2 here, that would make it negative 2. But the absolute value makes it positive 2, right? It's kind of like a back and forth thing, right? So what's interesting here is that why we have these two pieces is because the absolute value has a special rule, right? It's going to make your numbers positive. And so this line works for a little bit, and this line works for a little bit. That's basically what a piecewise function is we have part, but we need to talk about what is the interval. Like when is it this one, when is it this one? So oftentimes what you'll see is we'll put these together, kind of like in a little curly Q. That is the worst one I've ever made. And then we're going to write next to it what interval that would be true for. So when is x or y equals negative x, when is that the equation we're going to use here? Well, if we talk about our x's, it's when x is less than 0. So I'm going to write y equals negative x when x is less than 0, just like that. And then when is y equal to positive x? Well, that would be when x is the rest of them. We'll say greater than or equal to 0. So what happens here is this kind of tells you the domain of that function. We're only going to graph this function in this particular domain. And so this is kind of what the absolute value function is, right? Is we have this line only when x is less than 0. We have this line only when x is greater than or equal to 0. And that gives us kind of this absolute value v thing going on. But we can have pieces of a lot of different things. Let me show you an example. I forgot I got a new eraser. Ooh, that was smooth, baby. All right, so let's say we had y equals 2x plus 7, and I would like that when x is less than -3. And I want y equals 1/4 x plus 2 when x is greater than or equal to -3. So I want this piece over the domain x is less than -3, and I would like this piece when x is greater than or equal to -3. So what this is going to look like on my graph is I'm going to have two separate pieces of functions. Let me show you what that will look like. So let's do the first one. First of all, I only want it when x is less than -3. So what am I going to do at -3, right? Because it has to be strictly less than. Well, if you remember inequalities before, when we used number lines, we're going to bring that back, and we're going to use open circle at -3 for this equation, and we're going to use a closed circle at -3 for this bottom equation, showing that we're not including -3 at the top one, but we are including it in the bottom one. So if you want, always a good idea to kind of make a little table, like we talked about yesterday. So I needed that -3, and then we want less than, so we'll go -4 and -5 and see what's going on in that one. And this one, we want it greater than, so maybe we'll go -2 and 0 and 4. Just picking some points, right? So if I plug -3 in here, 2 times -3 is -6 plus 7 is 1. If I plug in -4, 2 times -4 is -8 plus 7 is -1. And if I plug in -5, 2 times -5 is -10 plus 7 is -3. So I have the point -3, 1, and I'm going to put an open circle there. I have -4, -1. And I'm going to have -5, -3. A little bit lower. All right, so this line right here is a piece of the graph. That's for this domain, x is less than -3. Just a little piece of it. And now we're going to graph this piece, right? So if x was -2, -2 times 1/4 is -1/2. -1/2 plus 1 would be 3/2 or 1.5, right? So -2, oh, I'm so sorry. We need to put we don't want -2, we want -3. Because we need to actually have our end point on here. That's a very important point for us. So -1/4 times -3 is -3/4 plus 1 plus 2 would be positive 5/8. 5/4. Sorry about that. So -3, and then it's a little over 1. You know, it's close to like right there. So we kind of have this gap. I kind of made this circle enormous. I didn't really mean to do that. We kind of have this gap in our graph. I guess I could keep going. If I plugged in 0, 1/4 times 0 is 0, plus 2 is 2. So the point 0, 2. And I chose 4 because I knew that was a nice one. 1/4 times 4 is 1, plus 2 is 3. So 1/4, 4 and 3. So this one's going to look like this. So if you see, we have these two pieces of our graph. And we're not going to do this with anything too crazy right now. Just a couple like linear things. Since we should be pretty good at graphing linear things, right? I would think so. Especially ones that are in slope-intercept form for us already. Oh man, my video is going to cut off. Ooh, that's depressing. Okay, so notice it would change my range up a little bit because now we have a section where there's not a range, but we don't really need to worry about that at this moment. Just kind of being able to get these pieces. My phone is going to cut me off. I'm not really done, but that's okay. I think maybe I'll just give you this much today and then kind of let you play a little bit and see how you can do, since it's going to cut me off anyway in literally 10 seconds. So, yeah, glad I saw that. I will do more practice, but remember, this stuff you're not going to be tested over, so it's not that big a deal. All right, I got to go. See you later.